Okay, so we're going to go ahead and get started. So our sole purpose for gathering today is to learn about the 2020 stream monitoring results for Lowery Creek. Mike Dagan, take it away.
Thanks, Barb. Jean's going to be my co-presenter today, so thank you, Jean. Thanks everybody for into the meeting today. We're happy you're here. We'd like to make this somewhat informal and interactive if at all possible. So feel free to ask questions along the way. What I'll be doing is introducing each of the descriptions for the parameters that we've been sampling for in this program. And then Jean's going to go over some of the details of the data. And then we'll give everybody an opportunity to ask questions along the way with each of the data slides. So here we go. And thanks, Randy, for this beautiful photo of the pond and the creek coming into Taliesin here. Very nice.
Welcome.
Okay, well, this is a reminder to everybody. Lowery Creek is a priority navigable waterway. It was not too long ago classified as a class 2 trout stream. And last year was reclassed to class 1, which was really exciting for all of us to hear. It's a great indication that there are good things going on here in the valley that are contributing to high water quality. So we're very excited about that. You'll also recall that Lowery Creek is a heritage brook trout stream, which means that the brook trout that live in the stream are of the native genetics that populated the driftless area throughout history. So very cool. The Department of Natural Resources uses these fish to get brood stock to stock other streams throughout the driftless and other parts of Wisconsin. Lowery Creek is considered a watch water because the phosphorus is a little bit elevated and it's close to the state standards. So I think one of the things that we want to do is see if over time we might be able to reduce the phosphorus so that we can perhaps one day rid ourselves of the watch water classification. Now, the unnamed tributary to Lowery Creek, which goes through the Hillside School Road Valley, is also classified class 1 trout stream, along with the main stream, and is also considered a watch water. If I move on, are there any questions? Just jump in. Okay. So these are the parameters that we've been sampling for during the wave monitoring program. They include temperature, dissolved oxygen, and percent saturation of oxygen, transparency, how clear the water is, stream flow, how much water is flowing, and biotic index, which is an assessment of the critters that live in the stream, and total phosphorus. We have 5 sampling sites set up in the valley right now. On the right-hand side of this map, you'll see the first sample site, which is the Cates Farm. And then as we move downstream toward Highway 23, the second site is the County Highway Z site. There's a site below the dam, just downstream from County Highway C at the top of the map. And then the fourth site is at Meg and Mike's farm on Hillside School Road, right here. And the fifth site is down on Highway 23. So just as a reminder, what we tried to do is we tried to set up an upstream monitoring site on the main stream, a downstream monitoring site, and also on Hillside School Road at the unnamed tributary, an upstream site and a downstream site. And then finally, the most downstream site where it's beyond the confluence of the streams. So it represents water quality of the 2 streams that make the pond and then eventually discharge the Wisconsin River to the north. So one of the first parameters we sample for is water temperature. And temperature can have an influence on the type of the fish community. And the metabolism of aquatic creatures increases as temperatures rise, resulting in greater oxygen demand. Fluctuations make fish and insects more susceptible to disease and parasite. So we like to see a nice steady temperature throughout. And temperatures over 75 degrees can be fatal to brook trout. Brook trout prefer temperatures in the range of about 53 to 57 degrees Fahrenheit. So Jean, you want to talk a little bit about what we learned about temperature so far in our sampling?
Sure. So for the next 5 graphs, they're going to look similar. You're going to see the sites on the bottom or x-axis, and then the parameter we're discussing on the y or the left axis. So as Mike said, 12 to 14 degrees is optimal temperature for brook trout. And it's not surprising that the Deegan Trib has the highest temperatures, as the flow there is quite low. And that indicates to us that there's less spring inputs. But regardless, all the sites are suitable for cold water fish. So we've got good cold water in both the Trib and Lowery Creek.
Great. Any questions on temperature, folks? All right, let's move on. So we have dissolved oxygen and percent saturation. So there's atmospheric oxygen that contributes to the oxygen in the water, photosynthesis from plants, and just agitation or the tumbling water can all contribute to the oxygen levels. And depending upon the factors at work, oxygen can fluctuate wildly. So dissolved oxygen levels greater than milligrams per liter support trout. And to have optimal conditions for spawning, we like to see oxygen levels just even a little bit higher than that, 7 milligrams per liter. Cold water can hold more oxygen than warm water. And trout use 5 times more oxygen resting at 80 degrees Fahrenheit than at 40 degrees Fahrenheit. And we're interested in DO and how close the value is to the equilibrium value for the recorded temperature. So it's a relationship between the temperature of the water and the amount of oxygen that is in the water. And I found this slide particularly interesting because temperature can really have a double whammy on aquatic life, particularly trout, right? So we learned that trout use 5 times more oxygen resting at higher temperatures at 80 degrees than at lower temperatures that are better suited for trout. But remember from our previous slide about temperature, what we learned is cold water can hold more oxygen than warm water. So here's the double whammy. In warm water, fish use more oxygen, but the warmer the water, the less oxygen there is. So a really important dynamic. Jean, take her
Good
away.
point, Mike. So dissolved oxygen is on the left-hand side on the y-axis and each site below. And actually that line, that dark line you see there, should be right at the 6.0 mark. I don't know what happened there, but so Mike explained DO of 6.0 can support trout, but 7.0 is optimal for spawning because it aerates the redds or the nests where trout lay their eggs. And you can see that the dissolved oxygen is above 6.0 and above 7.0 at all sites. So we've got good dissolved oxygen in both Lowery Creek and the Tribs.
Yeah, so that's encouraging. Any questions? Okay, let's move on.
So this is the percent saturation. And Mike explained that it compares the oxygen concentration to the absolute solubility of oxygen at a particular water temperature. So oxygen levels, they indicate how biological processes can affect the water, like community respiration by bacteria, by animals in the water. And the warmer the water is, the greater the use of oxygen, as Mike explained, the greater the organic matter decomposes and other bacteria take up oxygen. So for this slide, what you see is we've got pretty decent dissolved oxygen percent sat in Lowery Creek. And then for the tributary, it's not excellent, but it's still good. So you recall that the warmest waters were in the tributary at Dagan's site and State Highway 23 from the previous slide. So that's why we're seeing slightly lower saturation. So Lowery Creek then has excellent percent saturation, and the trib still has good saturation.
All right. Any questions there? Very good. So transparency, we measure transparency in the stream, and we use this device called a T-tube. As you can see, the young lady handing off a transparency tube that's filled with water to the team that's up on the bank. Silt from fields and animals in the stream, or construction runoff, or algae from fertilizers and silt contribute to negative transparency. So silt in that is going to, what happens with this T-tube is that we measure how much water the person's eye can see through this column in the tube. So when this tube is filled to the top and handed on shore, usually two people get on the tube. One person will be looking down through the top of the tube. And the bottom of the tube is called Secchi disc, and it's a black and white form that shows up when you're looking through the water column. But in very rare cases, will you be able to see the Secchi disc throughout the entire column? I think Dick Cates at one point said that he was able to see through the entire column, which is really quite rare. So what we do for the procedure is that we release water from the bottom of the tube, and the observer is looking through the top of the tube. And when that person is able to see the Secchi disc, then we say stop. And then we measure how much of that water column still remains in that tube. And then that gives us a measure of transparency. So from silt and animals in the stream and construction runoff and all that, that contributes to the turbidity in the stream, and it reduces the transparency. So long story short, the more stuff that's in the water, the less transparent it is. And the longer the water is turbid, more it negatively affects aquatic life. And that can be exhibited in increased respiration rates, reduced growth and feeding rates, delayed hatching, and in severe cases, even death. Jean?
Yeah, so you've got transparency, and that's exhibited in centimeters in the tube, on the tube. And the black bars are the single most poorest transparency over the 2-year period from 2019 to 2020. And the blue bars are the single most best transparency. So you can see, and Mike already indicated this, 120 is the top of the tube. So the Kate site had good transparency, or that's the highest transparency we saw there. County Highway Z, single most was fairly high. When you get to Highway C, it drops way down to 50. That's the highest we saw over 2 years. Dagen's pretty good at 83, and then the Trib at 23 kind of falls in between Mike's site on the Trib and Lowery Creek at C. So the clearest water then was collected from Kate's, County Z, followed by the Trib at Dagen. And the poorest sites were Lowery Creek at County C, Lowery Creek at C as well, and the Trib at 23. But you kind of expect if you have erosion is naturally occurring in streams, and if you have excessive erosion, you're going to see the least or the poorest water clarity down near the mouth of the stream. So that's why you're seeing those lower values.
Right. So as Jean described, it's expected that we will see poorer transparency the further downstream you go. And there are a lot of factors that can be at play there. But to me, this is one of those parameters that can tell us a lot. And hopefully, as we learn more about what we're doing on the landscape in the watershed, and the more we explore ways that we might be able to improve our land management and hopefully reduce erosion, then what we might hope to see over time is that the average transparency at our sampling sites becomes better and better. So that's one thing that I'll be keeping my eyes open for in the long term. But we have to remember too that when it comes to monitoring results, things don't experience dramatic change in short periods of time unless you have a cataclysmic event. So this is one for us to keep our eyes on, and hopefully it will serve as an indicator as to how well we're doing on working to improve our land management. This slide is a little busy, but it tells us a lot. Was there a question?
Yeah, this is Barb. Just wondering if the amount or type of vegetation in the stream affects the parameters that you've talked about so far very much?
Well, maybe I can answer to that. So if you've got a lot of vegetation in the stream, it can affect your dissolved oxygen. So you'll have like diel fluctuations, or fluctuations from day to night when you have a lot of vegetation. So you'll have a high oxygen level in the afternoon, and then as the plants are respiring and photosynthesis is no longer occurring in the stream with the plants, then you'll get a drop in oxygen. And I know I've been to some streams where I had oxygen, temperature, oxygen loggers in the stream. So they record the data every 15 minutes. And you can see these great swings in the oxygen at those sites where there's excessive vegetation. If you've just got a little bit here and there, that's fine, patches of it. But where it's really excessive and a long distance in the stream, it really can affect it at that area. Does that
Right.
answer your
So,
question?
so vegetation can have a positive impact on dissolved oxygen, but it can also have a negative impact too, right? So when plants are photosynthesizing, they're putting oxygen into the system. But when plants die off, think of a big algae bloom where the algae is dying, and what happens is that in its decomposition process, it consumes oxygen. So if you have vast amounts of plant life that are dying in a water body, it's consuming a lot of oxygen to decompose, and it's going to dramatically impact dissolved oxygen in that water body in a negative way.
Interesting, thank you.
That help, Barb?
Yeah, very much, thank you.
What's going on in this slide, Jean?
Oh, okay, so we talked about how you convert transparency to nephelometric units of measure. So what nephelometric units tells us is the turbidity of water. And so this chart can kind of help us understand the importance of clear versus very turbid water. On the Y or left axis, you've got the turbidity going from low up to high. And then over time on the x-axis, so hours, days, weeks, and months. And what this chart shows us is that the poorer the transparency, the higher the turbidity. So if you have a very low NTU, you have a low turbidity, and that's a good thing. But as you go up the graph, say you get to 100 NTUs, then fish start to show some signs of stress, reduced feeding rates, they cough, and as you go higher, you get up to 1,000 NTUs, then fish start to delay hatching rates. They start to leave the cover, try to get to maybe a tributary stream where the water quality is better. And really high NTUs can mean reduced growth rates and even death.
So turbidity, usually not that good. Clear water, that's what we want. Okay.
So this graph is kind of busy. I see I didn't put what was on the y-axis there, I'm sorry. So on the left axis is actually the turbidity in those units that we just talked about. And then on the bottom axis is each site. And the first two, the black bar and the light blue bar, those two bars, say for example, we're taking the Lowery Creek Kate site. Those first two bars are actually the median in 2019 and 2020 for turbidity. And then the second two bars, the green and the gold bar, are the most turbid in 2019 and 2020. So we talked about how at 50 to 100 NTUs for a duration of more than a few days, fish start to show some stress, reduced feeding rates, increased respiration. So what you're seeing it on this graph is that Lowery Creek at County Highway C in the middle of the graph there is the most turbid, excuse me, followed by the tributary way over on the right-hand side at 23, Highway 23, and then Lowery Creek at County Highway Z. So all other sites are low in turbidity. But since we only collect this once a month, we really don't know what the duration is for these values. You would have to go out, if you want to get really accurate about this, you would have to go out during a rain event and then subsequent days after a rain event in order to record the transparency and convert it to turbidity to see if it was happening over a period of time. Because if you just have a high turbidity 1 day or 2 days, that may not affect the fish much at all, or aquatic insects or other critters in the stream. But if you have a high turbidity over a period of time, it will affect them. So we would have to go out and monitor daily until the stream came back down to base flow. So in any case, I just do want to point out that the highest we saw was 100, which is nowhere near the 1,000 or 10,000 NTUs that we saw in that previous graph, where it's really bad for a stream. So we're getting a little turbidity in there, but still, in most cases, well under 100, except at Lowery at County Highway C.
Yeah, so this table is really illustrative to me, right? And it supports a notion that we talked about earlier in the conversation also. So let's just look here at the left, for example, the Lowery Creek at the Cates Farm, which we said was an upstream location, right? And considerable inflow from springs and the like. So a lot of groundwater discharge up in the headwaters of the stream. But then what this tells me is, as you go further downstream and you get to the downstream monitoring location at County Highway Z, turbidity is greater because there's more inputs to the stream. There's more erosion along the way. There's more runoff. And when we get furthest downstream in our sampling, that's where we have the greatest turbidity of all. So I think that's what we would expect to see, but it's also something that we'll want to watch over time to see if, again, we can improve on some of our land management and hopefully maybe one day see some of these values get lower.
Yeah, that's a good point, Mike. So at Cates, we have a very small part of the watershed there. And same with the trivet digging. Very small part of the watershed where corn fodder and runoff and soil erosion is occurring. And then when you're way down at County Z and C and Highway 23, that's taking in the entire watershed and all the activity going on there. So that's a good point. Well made.
Okay. Any questions? Hopefully we're not putting people to sleep. Okay, stream flow. It's another important parameter that we take account each time we go out. And essentially it's just the volume of water that's moving past a point during a span of time. And the values that we use are cubic feet per second. So cubic foot of water per second moving past a given point. Obviously, low flows may not support fish. And flow can be affected by runoff from rain or snow melt throughout the watershed and groundwater spring inputs, as we mentioned earlier, and is also affected by drought. So the more developed the watershed or the more compacted the agricultural soils are and the like, the more direct runoff you're likely to experience. Whoops, pardon me. And the flow of the water defines the shape of the stream bed, and its size and the course of the stream. And all this is integral to habitat, to food sources, to spawning areas, and migration paths of fish and other aquatic animals.
Okay, so the next 5 graphs are going to be a little different format. It's each site that we monitor for transparency and stream flow over each month that we monitor. So the date on the bottom. Transparency is the blue bar, and flow then is the black line. So flow, the value for flow is on the right-hand axis, transparency value on the left-hand side. So this helps us relate what's going on between when the stream, when we have rain and there's runoff and the flow increases, and you know, whether there's factors that are influencing the transparency, even when there's no runoff during normal flows. So in general, if you look at the transparency for Kate's, in general, excellent transparency, which we showed you in a previous graph. And even at the high flow level in August, you see where the peak flow is in August. Still good transparency at the Kate's site. So that tells us that there isn't upstream issues or issues right on the Kate's farm that are affecting the transparency when you get a rain event. So obviously there's some great stewards of the land there, as we know well from Kate's. But you might want to ask yourself, okay, in June of so the transparency is low and the flow is low, which brings to mind what's going on there. Well, Kate's do a great job of making notations on their data sheets. So when I look back at their data, they had a notation, cattle in the stream just above us, drinking prior to the sampling. So those cattle were in the stream, stirred up the sediment, and as a result, the transparency was low at the lowest flow. So that's really good. It's great to get people's notes on those types of issues going on at their site.
All right.
So our team we sample at County Z and County Highway C on Lowery Creek, and our team didn't collect flow in 2020 at either site. You can blame that one on me because I was afraid that handling the ball between 2 people might transfer COVID before I knew the facts. So we did not actually collect the flow. So you're just looking at transparency here at County Z. At any rate, the transparency is poor pretty much all the time.
pretty steady.
Yep.
Yes, and I think we'll see this in a number of our parameters. 2020 was just a weird year, right? It was the year of COVID. So we did have to modify or eliminate some of our monitoring parameters.
Oh, yeah, that's why we don't have May and June on these next graphs, because Kate's felt comfortable going out because it's Kate's, right? That's their team, their family. So, but in May and June, we were following the wave protocol not to even begin to sample. And then in July, they said, well, if you want to go out, it's up to you. So then we didn't start sampling at our other sites until July. So that's why you're seeing these parameters. Okay, so County Highway C, again, even worse than the previous graph, transparencies low throughout time.
And when we look at these parameters, it may cause us to wonder a little bit, like what might be going on. So this County Highway C site is below the Taliesin Dam, right? And this is the same time frame where the dam was drained or had been drained already, and a lot of sediment was released when that pond was drained. So I think it's very likely that that dynamic that was at work, and is still at work because the stream bed is flowing through a considerable amount of silt and sediment. And it's pretty apparent to me that because of that, we're experiencing these low levels of transparency.
Yeah, we did observe the stream head cutting back from that outlet tube at the former pond end of the pond where the dam is. And the banks were really steep and highly unstable. And there was just such excessive erosion going on. And, now when you visit the site, you see rock riffles as the sediment is moved down to our site here, just below County Highway C. And I find it really amazing that a stream works so hard to get back to its original configuration, down to its original bed, to correct the issues that rose from all the anthropomorphic sources of the past. So a lot of times in a farmed watershed that's heavily farmed and the right practices aren't on the land to keep the soil on the fields, those stream banks build up and up and up, and the stream can't get out of its floodplain. So it digs down deeper because it can't get up and flood the surrounding area when there's a rain event. So it just keeps cutting down, and that's kind of the case in what we observed at that site.
All right.
So this is transparency and flow at the tributary at the Dagan site. And transparency in August was good, but poorer in all the other months. While flow is low and fairly stable from August through October, but high in July. So then again, here you're thinking, okay, you've got this high flow in July. Then why is the transparency in July so similar to September and October? Well, one would think that, you know, at the lower flows, the stream should be clearer. Well, we know Mike and Meg are really good land stewards. They've got a great, nice prairie buffer along the stream. So what this data kind of helps us do is to see if there's likely a human or agricultural impact, like perhaps wading cattle in the stream upstream of the site, or barnyard runoff coming in upstream of the site and causing, you know, overall poorer transparency for that July, the month of July. And it doesn't appear that it's an anomaly in the data, because we also saw high flows at the Cates and Highway 23 sites in July.
All right.
So something's going on upstream is what we're saying, at least in 2020.
Now the Highway 23 site.
Yeah, so transparency poor in all months, regardless of the flow levels. And there really wasn't any good correlation between the flow and the transparency at the site. So it tells us there's likely constant active bank erosion down in this area. And I think even Randy and Mike alluded to the fact that there were maybe a lot of trees down and a lot of erosion where those trees are collapsing into the stream, a lot of erosion behind on the bank. So that's something that, you know, we'll want to take a look at in the future and look at that site in terms of the amount of erosion occurring there.
Yeah, Gene, I think too, every time Randy gets in the stream, he notes just how significant the sediment deposits are in that part of the stream. So I think there's a really heavy loading going on, loading of sediments to the stream going on upstream. And the flow seems to slow at that sample site, partly because of the downed trees in the area. But just the fact that there is so much sediment in there, I think anytime you get flow, that flow is going to serve to keep some of that sediment suspended. And I think that's contributing to these poor transparency values.
To add to what Mike was saying, where that tree branch has come down on the corner just below our testing site, we always try to monitor the creek at the same spot because we have some highway marker that we can use. When we first started, the sediment was maybe 4 to 6 inches deep on my boot. And after that tree had fallen in the creek, and it's been there now for a year and a half, we're at 18 to 24 inches deep in sediment. It comes up above my knee almost. So with the slowdown caused by that tree, we've had that much more sediment deposit on the corner there, which I thought was real interesting.
Yeah, so there's some negative and some positive there. A lot of erosion from those trees that fall down. But on the other hand, in some cases in these streams where in the locations where you don't have a lot of rock riffles, a lot of rock for habitat or attachment by aquatic insects for fish to feed on, those logs provide habitat and cover for fish. So there's kind of the good and there's the negative of those trees when they.
Your point on that, Gene, I brought it up to Justin and I showed him some pictures and discussed it with him before we made the efforts to go in and cut it out or whatever. And he brought up the same point. In some situations, they're extremely helpful to have there. In some situations, the way they fall in the creek, they're better off to be removed and stuff. So that is a very good point. And he actually said it's happening up in the Pine River and the Richland Center area where they're actually removing too much from the streams and affecting the habitat that you were talking about.
Interesting.
Yeah, good point. So, in a perfect world, we might see real direct correlations between flow and transparency. I think these last several slides have showed us just how complicated the dynamics of a stream can be. And we don't necessarily have really direct correlation in every instance. And seems to be the one closest. We get to collect critters and see what's actually living in the streams. So aquatic macro invertebrates, or the aquatic stage of these insects, are in the stream. There'll be clams, snails, or crayfish. And they are all sort of the canaries in the coal mine, or the canaries in the stream to us. They are, and what lives in the water is an indication of water quality. And some of these species are very pollutant tolerant, means they can withstand a fair level of pollutants, while others are really sensitive to pollutants and can be impacted dramatically by slight rises in pollutants. Macroinvertebrates are relatively immobile in their larval stage, so they don't get around in the stream. They can't escape the conditions that they're subjected to. And sometimes they can tolerate short periods of pollution. Other times they may not be able to tolerate longer term pollution exposure. So heavily polluted streams lose these sensitive species, leaving only the most tolerant of aquatic species.
Which then also means that the fish in the stream don't have the diversity or maybe the type of insect that they require. For example, trout and mayflies. So on this slide, again, we're back to each site on the bottom or x-axis, and I forgot to label the left-hand side, which is the biotic index score. And in the upper right, the score then relates to a rating. So for example, 1 to 2 is 4. As you go up the scale, a score of greater than 3.6 is excellent. So biotic index rated good for Lowery Creek at Kate's, County Highway C and County Highway Z. And the trib at Dagan was on the upper end of fair, and the trib at State Highway 23 was 4. So it tells us at State Highway 23, there's a long-term pollution problem that's occurring there.
Yeah, that site's not that great. I think
Right.
I'd like to make this note about biotic index. I think what we learned too is a lot of us were newbies to this monitoring process in the last couple of years. And I think this is one of those parameters where we're still improving our methods of collection. So I think what we might likely see in years to come is that this biotic index will inch up a little bit at some of our sites because we're getting better with our methods of collecting these critters. So if we do see that change, we need to be careful about what we read into it. In other words, there are a number of different factors at play here. And the one that I'm bringing up right now is the method with which we're collecting these insects. I think we're still getting better at that as time goes on.
Yeah, I agree, Mike. You know, I actually went out last fall to Dick Cates' site because he asked if I would come because he wasn't sure about his identification. And when I went out there and we went through the monitoring techniques, we talked about how he said, well, I've been pretty much concentrating just on the rock riffles and that's it. And I'm like, well, if you've got, undercut banks and you've got woody debris and you've got overhanging vegetation that goes down into the stream, the insects are attached there as well. So you want to kind of hit all those at once. So I think his score actually went up because also there was a little misidentification. So what he thought was a more tolerant species turned out to be an intolerant species. So it bumped up the score a little between 2019 and 2020. And I would say, the reason the trivet 23 is so bad is you pretty much said it in previous discussion that there's so much silt there. What do they have to attach to besides logs and maybe some, if you're lucky, some overhanging vegetation in the stream? But if you've got raw bare banks, you don't get that either. So you're basically kicking around in silt where you're going to have the poorest aquatic insect and the poorest biotic index score as a result.
Yeah, this is an interesting and fun one. Without fail, people just love to see the critters that get collected and go about the business of identifying them and learning about what we're seeing and what it says about the water quality of the stream. So this is a really fun one.
Yeah, and maybe, Kim also collects, Kim Cooper, the biologist who's online, also collects aquatic insects, and it always takes a long time for that data to come back. But maybe she can fill us in on what she's found at these sites, and maybe it's way different than what we're seeing here. So the analysis for that is much deeper than what we do as citizen wave monitors. All the collection, the collection she makes gets sent to the Stevens Point lab where they look at genus and species of each aquatic insects in the sample.
And Jean, I did get those results back from my sampling last year. I haven't had time quite yet to dive into it, but yeah, we did get those samples back, those results.
Great.
And great, Kim, I look forward to working with you and tying the data that you're amassing with the data that we're collecting and just try to put the pieces of this puzzle together and get a more complete picture. So we really appreciate your work in the watershed.
Oh, yeah, well,
Yes,
it's
we do.
great to be able to work with you guys. Pretty fortunate that way, so.
Awesome. Okay. Habitat.
Can I ask a question about insects first?
Yep.
Sure.
Yeah, I'm just curious, you were talking about the Highway 23 stretch being problematic. How much movement is there up and down the stream of insects? And if you have a problematic spot like that, does that affect, populations very much of insects and other aquatic critters?
Yeah, that's a really good point, and that's why that's one of the reasons we call them the canaries of the stream, because they don't have the ability to move very far when they're in their nymph stage. They're either at the mercy, so they're attached to rocks and debris, to vegetation, to logs, and rock riffles to the rocks. They're underneath those types of debris, and they don't have the ability to move unless they're washed downstream during a rain event, and they pretty much can stay in one spot, even in a high, flood event. But if they're kicked around by cattle, or say someone's wading in the stream and fishing, then yeah, they're in that stage. They can move, but they're pretty much limited until they go from the nymph to the naiad stage, and then they come out of the water as terrestrial insects, damselflies, dragonflies, mayflies, etc.
Okay,
Good, Barb?
yeah,
All right. Okay, then we're moving on to in-stream and riparian habitat. And this is an assessment where we use our visual skills and visual measurements of the condition of the bank and in-stream habitat conditions to help identify land uses that may be affecting water quality or stream health. And that could be either for the better or for the worse, right? So information is gathered on the riparian vegetation buffer type, the width of that buffer, and observations are made about bank erosion as well, and land use. It notes whether there's cover and shelter for fish and other aquatic animals, including pools and their depth. And it addresses spawning substrate and rearing habitat, like is it rocky or is it silty? For fish and aquatic macroinvertebrates, this is also evaluated. So the habitat functions holistically, so changes to any one part may affect the entire habitat system.
So I just want to point out, Mike, can you go back?
Sure.
Thank you. I just want to point out, we're at Dick Cates' site, and kind of look at the riparian habitat here, because I'm going to talk about that in the next slide.
Yeah, and let's make some observations. Look at these nice,
yes,
softly sloped banks, right?
vegetated all the way down
Yep, it's not bare
in
at
the
all.
stream.
And it's vegetated way away from the stream as well. So these are generally good conditions that you'd like to see in a stream environment.
So we did not do habitat in 2020 because it requires that you're next to one another in the stream, and you're using the same equipment, handling it back and forth. So we only have the 2019 data. Hopefully, we'll all collect the 2021 data. So as you can see, the excellent, the prize for excellence goes to the Trib at Dagan's site. Excellent habitat there. Really good riparian buffer, vegetated buffer. Other attributes like a good undercut bank at the site, which undercut banks then provide fish cover. Overhanging vegetation, which when the stream is at least 8 inches in depth, provides good cover for fish. And then some rock riffles as well. So those types of things can bump up that score to an excellent. Let's go back to Lowery at County Highway C for the habitat there. County Highway Z, excuse me. So this had a good rating. It had good undercut banks. It had overhanging vegetation in enough stream depth for cover. It had rock, not a lot, but some, and it had logs. So it also had deep and quiet pools, which is good for fish for resting and cover as well. Lowery at Kate's was fair. And the data collectors there, the Cates family indicated that there were fine sediments, a lot of silt, extensive in all habitats, even though they do have a lot of rock riffles. Pools were rare, which when you're high up in the driftless area, streams and you're high in the landscape, you don't often see pools in these small streams. Anyway, so pools were rare, but then cover for fish was rare. Not a lot of undercut bank. Not a lot of boulders, which they have to have boulders and not just smaller rock to kind of hide around and rest next to, and not a lot of logs. So that kind of brings that rating down a bit. I
That's
also.
an interesting one. Oh, can I make this comment, Gene, please?
Sure, yeah.
That's an interesting one because just a moment ago, we were talking about how nicely the stream banks were being managed. They're gently sloped and well vegetated. And because of some of the other factors, the rating comes down. Although there are other factors that play throughout the Cates system up in that stretch of the stream that are really, really beneficial to the fish population, right? They do have those rocky riffles that are good for spawning. They do have the inflows from significant springs. So, and they do have great dissolved oxygen, and they do have great transparency. So there's a lot of factors at play that contribute to water quality. And in this case, perhaps some of the habitat isn't the greatest at all levels for all life stages, but really, really good for, say, reproduction and rearing of young.
Spawning and rearing and aquatic insects, so feeding of fish.
Okay.
Yeah, so and Kate's, what I noticed on their form, the collectors, they indicated that the riparian zone habitat was well protected and excellent, and Mike pointed out that it is, but for the purpose of collecting this information on habitat, when you use this method, and the DNR also uses this same form, if you have a vegetated riparian buffer that is like they graze, compartmentally graze, move the cattle around, is still not considered a good buffer on a stream. So if it's grazed, it's still not considered a good buffer. Now, if it was in meadow, or like at Mike Dagan's site, if it's all prairie plants, that's considered an excellent riparian buffer. So that fair score came down quite a bit because of the fact that their buffer is considered, the score on their buffer was a 0, which is the poorest score you can get, even though it's compartmentally grazed. And maybe that's something that, over time, the science of that changes. I don't know. You know what I mean?
Yeah, well, here's I think one of those interesting dynamics that we're faced with often when we talk about the work that we're doing here in the watershed. And to me, it is the fact that agriculture is a really important part of our society, a part of our community, right? We rely on agriculture for so many things, whether it be food, whether it be supporting the families, employment, economy, all those things. So agriculture is going to be, and has been, and will always be, a really important part of our society. And what we need to do is is to continue to work to strike a balance between agricultural practices and try to find ways, try to find practices and get them in place that are friendly to the stream as well. So in that regard, the farmer's our partner, right? So we want to continue to work with farmers and recognize the need for farming, but then also try to encourage the implementation of good land use practices like the Cates are doing.
Yeah, to me, there should be a difference in that buffer score, where if you see an absolute bare bank because of excessive cattle grazing and it's just raw soil, that's a 0 score. But that's just one part of this whole habitat collection that we do. So I guess I'll just move on. Lowery Creek at County C had the poorest of the fair. That makes sense. Not surprising. Ryan will tell you, silt up to your hips if you try to move downstream. Really, the only cover is woody debris as you move down. Not much, there's no undercut banks. There's a little rock riffle just above our site, but other than that, it's no boulders. So not a whole lot of habitat there either. I guess what it's got going for it is it's got taliesin protecting the bank habitat, so it's naturally vegetated. And there are trees along the bank in that section.
Okay. And then lastly, there's phosphorus. So the state standard for phosphorus in small streams is 0.075 milligrams per liter. Any higher levels exceed the standard. It's important to note that phosphorus is naturally occurring in soils. The major sources of phosphorus are from human activity, including soil erosion, human and animal waste, septic systems, detergents, and runoff from farmlands or lawns. And phosphorus can be bound up in sediments. So we sometimes refer to legacy phosphorus that is bound up in sediment and deposited in stream banks that can be reintroduced into the water. It can reduce water transparency. It fuels plant and algae growth, which in excess die and decompose, gobbling up oxygen used by aquatic animals. And we touched on that just a little bit earlier. So what do we learn about phosphorus in our sample?
So phosphorus is a good thing. You've got to have phosphorus or you won't have phosphorus and nitrogen, because that's what fuels your plant growth. And you want plants in streams. So some algae and some plant growth is great, but when it's excessive phosphorus, or we've even seen in situations where it's excessive nitrogen, then you just get, it feels algae blooms off the map, and that can shade out, good plants in the stream. And so phosphorus is a good thing, but in excess not. So phosphorus is on the left-hand axis and each site on the bottom. And the state standard, as Mike said, was 0.075 milligrams per liter. And so for Lowery Creek at Cates, it's well below the state standard. At County Highway Z, it's just below the standard, but above the standard at County Highway C. At the Trib at Dagan is exceeds the standard, while the Trib at State Highway 23 greatly exceeds the standard. So this kind of gets into Kim Cooper, the biologist camp. Perhaps at a meeting down the road, she can talk more about this, because they have to support impaired water listings for phosphorus with biological data. And she's, I'm sure, so busy with this summer that she'll probably write up the report at a later date for this. So, and then they submit this to central office for an impaired waters listing for phosphorus if they feel it's supported by biological information. So hopefully at a future meeting, she could address this and see where they're going with their biological data and impaired waters listing. Because if water is impaired, you want to work to get it off that list. And as one of the means to do that is you get state funding for farmers to put in good practices that will help reduce phosphorus, like grass waterways or sloping the stream banks and putting rock on the raw soil on the bends of streams, things like that. So protecting the bank and protecting the watershed, essentially. So.
All right. So that's our presentation on our monitoring results. And I think maybe just a couple quick notes would be appropriate. I think what you saw is in a lot of our slides, we were sharing mean values, average values that between the 2 years of our monitoring work. And the reason we did that is because we have one reason is there's a small sample size of monitoring dates, right? Of monitoring data in general. And I think as we look at water quality data over time, we would hope to see some trends. We would like to see trends of improvement as we continue to work with our partners in the watershed to implement good land use management practices. But these changes don't occur quickly over time, but rather occur over long periods of time. And that's why averaging the values that we get are going to be a more valid way of looking at our data. Otherwise, we may be scratching our heads over a high value one day and a low value the next. But if we average those values, then we might be able to see trends over time.
Yeah, and then those median values, you know, they will kind of take out the outlier values that you might see. So, yeah, that's good stuff. We need to collect more years of data to see more of the trends that are happening in the stream, in the watershed, I should say.
Right, so I'm going to stop sharing. And if there are any more questions, we'd be happy to address those. Otherwise, that's the presentation that we have for you today.
Yeah, and we
Thanks,
want to
Mike.
thank
Yeah.
all our water action volunteer monitors, past and present. That wasn't the whole group of them in the last slide, but we really appreciate the work all these people do to help us figure out what's going on in this watershed.
Mike, could you open that photo I put in chat of the crayfish at your place? I was just curious.